we're going to do question 10. We're having a graph of h of x, which is equals to ax to the power of 3 plus bx to the power of 2. And the turning point passes through the origin of 0 and 0, and another turning point of b, which is 4 and 32. So a is an x-intercept of this graph of h. So here is the graph, and every information is indicated. So let's do 10.1. So we are asked to show that a is equals to -1 and b is equals to 6. So for us to do that, we're going to use the information given. We know very well that h of x is equals to ax to the power of 3 plus bx to the power of 2, right? And we can use this point here of 4 and 32 and substitute it in this equation here. So here we're going to write 32 is equals to a into 4 to the power of 3 plus b into 4 to the power of 2, right? So this is 4. Let me write it nicely. So 32 is equals to a into 4 to the power of 3 plus b is into 4 to the power of 2. So we're going to get 32 is equals to, so 4 to the power of 3 is going to give you 64, a plus 16b, right? So this would be your equation 1 for this problem here. And you're going to write h of x being equals to ax to the power of 3 plus bx to the power of 2. So if we derive this and substitute this 4 here, right? So we're going to say h prime of x equals to 3ax to the power of 2 plus 2bx, right? So we know very well that this will be equals to 0. So 0 is equals to 3ax squared plus 2bx, right? And we substitute x is equals to 4, right? So it's going to be 0 is equals to 3a into 4 squared plus 2b into 4, right? So 0 is going to be equals to 3 times 4 is going to give us 12a. Let me correct this. So here it's actually 0 is equals to 3a into 4 to the power of 2 plus 2b into 4, right? So it's going to be 0 is equals to 4 to the power of 2 is 16, right? So it's going to be 16a times 3 plus 8b, right? So we're gonna get here 0 is equals to 48, right? A plus 8b, right? So then now this would be our equation 2. Then I'm just gonna create equation 3. Remove everything here. So now we have equation 1 and equation 2, right? We just want to identify the value of a and b. So for us to do that, to equate equation 3, so I'm going to use this equation here. So I'm going to say, I'm going to transpose this part to the other side and remain with 16b. Let me write the 16 properly. So it's 16b is equals to 32 minus 64a. So I'm just using this equation here. Divide by 16 all sides. So b is equals to 32 over 16 minus 64a over 16. So b is equals to 2 minus 4a. Equation 3, right? So now we have equation 1, we have equation 2, we have equation 3. So we're going to find the values of a and b, right? So let me just write everything properly. We're having 32 is equals to 64a 16b. So this is equation 1. and we also have 0 is equals to 48a plus 8b, so this is equation 2, and then we have b is equals to 2 minus 4a, this is equation 3, right? So what we're going to do is this: we're going to substitute equation 3 into the unused equation, which is equation 2. It's going to be 0 is equals to 48. Let me write this 48 nicely. So it's going to be 48a plus 8 into, where there's b, I put 2 minus 4a. 0 is equals to 48a plus 16, because it's 8 multiplied by this 2 here, and then 8 multiplied by this is minus 32a. So you collect the like terms, so 0 is equals to 48a minus 32a plus 16, right? So 0 is equals to 16a plus 16, right? Transpose the 16 to the other side. We have 16a is equals to minus 16, and divide by 16 both sides. So therefore our a value is equals to negative 1, right? Then to find b, it's now simpler. So we can use the third equation. Third equation says b is equals to 2 minus 4a. Whereas b is equals to 2 minus 4, our a value is negative 1. So b is equals to 2 plus 4, which is equals to 6. So we found the value of a and the value of b. Okay, so now we're going to do 10.2. Calculate the coordinates of a. So now we found that a is equals to negative 1, b is equals to 6, right? So the equation of h of x, which we are given as h of x, is equals to ax cubed plus bx squared. So which means going to be h of x is equals to minus x cubed plus 6x squared. So to find the value of a, which is this one here, we need to equate this to 0, right? Equals to minus x cubed plus 6x squared. And then just gonna divide everything by negative. I have 0 is equals to x cubed minus 6x squared, and then I factorize. I'm gonna have x squared into x minus 6 equals to 0. So x squared is equals to 0, therefore x equals to 0, or x is equals to 6, right? So the only possible value of a should be this one here, x being equals to 6, because you look at where it's situated. So the value of a is 6 and 0, right? So now we are done writing the coordinates of a, so let's go to 10.3. But before I do that, let me just erase here. Okay, so now we have write down the values of x for which h is in 10.3.1 is increasing. So how do we know that h is increasing? This point of the graph is decreasing, but this point of the graph is increasing. This point of the graph is decreasing. So to find the values of x when this function is increasing, we're simply gonna say look at this point and this point. This point, my x is 0, y is 0, and this point my x is 4. So x should lie between 0 and 4, right? Then now for which values of x will the function be concave down? So what we're gonna do about this concavity interpretation, we're gonna first find our x value of the point of inflection. We don't need to find a second derivative whatsoever. We can just find the mean of these x values of the turning points. Here x being equals to 0 and here x being equals to 4. So it's 0 plus 4 over 2 is equals to 2. So x of the point of inflection is equals to 2. So now let's say that equals to 2 is somewhere here. X is equals to 2. And then they say we must write down the values of x when it's concave down. So the function is concave down from that point going this direction. Excuse me. So that is when x is greater than 2. So when x is greater than 2, the function is concave down. Then now we're having 10.4, which says that for each values of k will this expression here be equals to 0 have 1 negative and 2 distinctive positive roots, right? So what this means is, remember that h of x was equals to minus x cubed plus 6x squared, right? So what they did here, they just substituted. So to find the equation of f, they substituted the shift of x minus 1 equals to 0, right? And then they substituted inside the bracket, so it's x minus 1 close bracket to the power of 3 plus 6 into x minus 1 close bracket to the power 2, right? So that is the shift that was experienced by this function here. So to find the solutions to this, let's first draw the case. So if the shift is x equals to 1, right, it means now that the function, the original function, looking at this diagram here, let me first erase. When x is equals to 1, where there was a turning point is going to move 1 unit, so which means it's going to move here. It's going to be 1 and 0, and then this would move somewhere here, right? So it's going to be, so the new turning point will be 5 and day 2, and then so yeah, this point here will move because it's gonna look like this, so it will touch this point where it's 0 and 7, right? So that would be my the function of the new shift, right? So for us to be able to identify the value of k, we should first look at the where x is 0 or x has a specific value. So at the y-axis, which is the y-intercept, right? X is equals to 0, right? X is equals to 0. So for me to find the y-intercept of this portion here, I'm gonna place x being equals to 0. So I did that and found y being equals to 7, right? So if you substitute negative into 0 minus 1 cubed plus 6 into 1 minus 1 squared, right? So okay, this is 0, not 1, hence we'll get the value of 7. Anyways, so yeah, that is the first value, which is 7, and we can conclude that for this problem here, and simply say k must lie between 7 and what's this number, and 32, right, and 32. So this would be the final answer for the last question. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comments section below. Don't forget to subscribe to the channel for more videos.